Okay, so as you might remember, during the last lecture, the last exercises we have been working on the custom begin class, and we mostly have completed the things we wanted to do during the lecture, and the other things are homework. So this time we will need to start for exercises something new, and a very good example of an own container type that is often very useful is a string container. So as you know, the normal plain C does not have dynamically length strings. You can only use arrays of characters which have a fixed length. That is not ideal in many use cases. On either you lack space and then you need to reallocate the whole memory, or you allocate too much memory and then you are wasting resources. So what is very useful in C++ is the ability to use so to say self-made strings. If you are using the standard template library, they are giving you actually a own implementation of strings, but since we are doing the things low level, we will not want to rely on an existing framework. Instead, we will be creating our own implementation of a string, and for that we create a new project. Let's call it xstring. And this practice of creating your own container types, or generally extending the C++ language with own helper objects is quite common. When you look on a lot of improvements that have been introduced to the C language over the years, a large portion of them have been just implemented as features in the standard template library and not technically constitute a new language feature, in the sense that the compiler itself needs to do something different. You're just given a bigger toolbox of pre-written template code. So since strings can be either normal 8-bit ASCII strings, or they can be 16-bit Unicode strings, it is a good decision for our own string class to implement it as a template class, so that it can be used with either type of character. So for that we create just a new header file, xh. So the whole implementation will be in the header itself. And well, let's start. Of course, for starters, we will want to have some constructor that doesn't do anything, just to have it. We will at some point want to have a destructor, since we need to release whatever data we hold internally. And what would be very useful would be a constructor which allows us to initialize the string from a normal C-style constant length character array. And we'll do it such that we can either specify a length or not. So if we specify a length, then length is used. If we don't specify it, then we need to count the length until the terminating null character. As you surely remember in C, it is customary to end strings with a null character, which is a little bit error prone, so more reliable string implementations usually use a dedicated length variable, and we will of course do the same. This also gives us the ability to create strings which actually contain null characters inside of themselves. So there are some use cases where this is useful. For example, if you want to make a string list that is easy to traverse, this is one of the methods that you could implement it with. So now of course we will need some internal data structure to hold the data. and we will need two variables, one to hold the length in characters, which will represent how much data valid data there is in the string. And at the same time, since usually when you are working with strings, what you will be doing is concatenating multiple string segments together. So in order not to allocate memory each time we add some text to a already existing string, what we will do is we will allocate a larger but only slightly larger memory block, and then only expand it from time to time when it shows to be needed. So we need a second variable which will hold the actual capacity of the string, so that we know how much more we can put into it. And then we of course need the string itself. We'll use such a zero length array like we used the last time in our begin, so that we don't need to allocate two memory objects at the same time, so that we can only work with having one object allocated. That improves the performance of our string. And then of course we need a variable to hold it. So until now it's quite analogous to what we did with our begin. However, here we have not yet added any copy and write mechanism, so we might do it later, but for now let's make a string which always gets fully copied whenever it is assigned from one variable to another. Later we can improve this using a move constructor, which allows us to, when returning a value, to avoid copying the whole thing one time extra. Okay, so let's see what we can, what we need as a base before we can assign to you some tasks. It certainly is useful to have some helper function that allows us to get a C-string version of our string. So we will need to internally ensure that our string is in fact internally null terminated. So for example, the string provided by the standard template library is also made such that it always contains a terminating null, even though it has a length variable. This is quite helpful if working with various older API functions which expect just a standard C-type string, and it's only one character extra, so it's not really much of a performance hit to always add this character at the very end. Then we of course will need to make something to allocate the string, so it will be a function static sx string, which will take it will take the capacity and it will allocate the whole data structure for us, which we then can use to assign it to our variable. So first we need the total size of the memory which we'll be allocating, which is just size of t times capacity, size of t times capacity plus 1 for the terminating null, which we want to always have one character extra, and this plus size of x string. You can actually improve that. If we make this 1 in size, then we can skip this plus 1. It's a very minor improvement, but it is an improvement, so why not? So we just set everything inside our newly allocated memory to 0. And one thing we don't want to be 0 is the capacity, which we set to our capacity. Should write a comment that that this is would be the capacity of the string, not counting the terminating 0. Okay, and then of course we'll need something to free the data later on, so void if m free m and m is like 0. Good. Of course we will need to call the release from a destructor, so that otherwise things will be freed and we don't have a memory leak, and we can now use our create to implement the simplest form of this constructor here. So first of all, we will assume that we have a length, so here we add a to do. If this equals -1, this will need to be done. Then we just assume it was done, so m is equals and if we are creating from a fixed string for at the beginning, we'll just take the existing length for the capacity. We will not over provision the string from the start. Only once we start adding to the string and we say, the string is used in a way that makes it grow, then we will try to allocate additional data. Now we check if we actually got a buffer passed, because we might not have gotten anything. So if this was passed, then length length use memcopy to copy the data, comma paste comma. Now we again need the size, so u times size of t. Last thing to do is of course to set the terminating null, which is very easy. We just address the array at the length offset and set it to null. Okay, so this much to the preparations, and the first assignment to one of you will be to do this to do. So what we need is we will need a function which will count the length of a string. So let's just write down the function prototype. We can use it here internally. Static size t x then just takes a string to do and counts the bytes. So let's see who has not yet done anything. Maybe Mr. Alexander would like to implement that. Do you remember how to connect to the machine remotely? Hello. You need to connect to the machine remotely as we did in previous lectures, and then you can implement the function and here the condition so that we retrieve the length in case the length was not provided. And of course in our main function here create a simple test case which initializes our string. Okay, wait a second, I just I don't want to make the IP public because the recording later goes to YouTube. So you need the tool VNC Viewer from VNC. I sent you the link for that. So it's the link for the VNC Viewer is in the chat. You can download the version matching your operating system and install it, and when it starts the first time it asks you to log in, but there is a button where you can press continue without logging in, and this works. Then you just need to provide the IP address where you want to connect to. And the IP address you will get in a second. I will also write in the chat. I just need to check whether it's changed because it might change from time to time. Right IP to connect to. Should be this one. So once you have the tool installed, you can provide a server address and use the address in the chat, and the password is also in the chat. And once you have the connection, you can control the mouse and keyboard of the machine that is shared and recorded, and then you can start working on it. Is it working? Can you connect? So the tool is running, but it's not connecting. It's not asking for password. Interesting. Let me try quickly. Okay, that is not good. Why is that not working? The IP address changed. Okay, try this one. That one should work. So the first step is just to implement a simple if condition at the top, which is already half done in the comment. We just want to check if u length is -1, and if it is, then assign u length the return value of extralen, where pstr is the argument. What seems to be the problem? Mm-hmm. Are you using some special keyboard? Normally, the brackets you can get on a German keyboard by pressing Alt GR and 7 for the opening and 0 for the closing bracket. So you don't need to copy them from anywhere. You can just type them normally on the keyboard. That is not great. But can you just type normal characters? Okay, then maybe maybe Mr. Jakob. Hello, hello. Mr. Jakob Wetzel, are you there? Doesn't look like it. So maybe in this case, Mr. Clemens. So what we want to do is just to simplify the thing. You just need to implement the body of the xStringLength function, which task is to count the length of the string until it until it encounters the first null character in the string, at which point it should return the length, not counting the null character. So it's quite a simple function. And of course then we will need a test case in the main CPP to test whether it works correctly. Yes. Yeah. Not necessarily large, but in this case a string of a variable length. So as you know, normal C strings, you always have to define how long your character array is, and if you define it too big, you are wasting memory. If you define it too small, then you cannot fit all the text you want into it. So the best solution is to have a string which can dynamically grow as needed, and this will this new helper object do. Yes. Well, it will be returned, so you can create a helper variable, give it whatever name you want, and then just return its value. You don't because it's a static function. You just need to access the argument pstring, and we don't know the length. That's the whole thing. We have in past a normal C string which is null terminated without any additional information. So we need to generate this information now. Mm, Yeah, that would be a option. A p string in the argument line 54. P string in line 54. The argument that is passed to the x string length function. You can use the current length as a argument in square brackets. This gives you the character at a given position. The only downside is that once you are at the character null, at this point your current length will be already too large by 1, so you will need to subtract 1 at the end. You just compare it whether it's 0. You just compare whether it's 0. So no matter what type of character is used, whether it's a normal char or a vchar underscore t, it can always be compared to just null, and then we know that that's the terminating character. So there are no differences, which makes it easy to implement a template-based solution. If the different string types would be using different numerical values for the terminating character, that would be a mess. It would also be doable, but you would then need to provide not just the type, but also the character to check for in your template definition, so it wouldn't be ideal. Wait, you don't need the -1, because if you are checking at the index 0, then this corresponds to length 0. If you're checking at the index 1, that corresponds to the length 1. So actually it's fine to use it'll use it directly without subtracting anything. And the type is cx string, and you need to include the header as well. It needs to be in normal quotation marks. Yeah, the pointy brackets you use if you're including something from some library folder, and you use the normal quotation marks if you're including something from your own project folder. I guess the only reason why they made it different is such that cx string. first class, then but you are missing. You need to specify the template type. So after cx string, you make pointy brackets, and inside the pointy brackets you write either char or feature_t, depending on which character you want to use. You need to use the constructor, so you need to after the variable name open round brackets and pass the string. No, in the same line when you create it, as it's the constructor. Once it's created, it's too late. Yeah, we should add a length function maybe that returns the length. That would be helpful as well. There is a cstring function which returns a copy of the buffer, and you can add a length function as well. No, there is a variable. You just need a function on the class which will return the content, because you cannot access m from outside, as it's defined as protected. So in line 25, you can just copy it and give it a new name, and instead of t asterisk, you just return size t, and instead of p data, you use the ulength. No, that needs to be there. It needs to be in the class definition. Yes, otherwise we would not be able to access it. And the name should be changed to length or something, otherwise it will conflict with the already existing name. And in line 30, we need to return something different, not p data but ulength, and then instead of null ptr, just 0. You need to return mu length. Just ulength will not be found in the scope. That should do the trick. No arguments. That was my mistake. I may have the mouse for a second. We need to return, of course, what we have created. Now it should be fine. Let's run it again. Okay. Looks correct. Perfect. Very good. Okay, so let's see what will the next function to be implemented be. So we could either implement an assignment operator and a copy constructor. That these will be quite useful to have. So let's do that next. Who would like to do it? Waiting for volunteers. Okay. So it will be a copy constructor and assignment operator, since they are let's put it like this. You can implement the copy constructor by invoking the assignment operator. So the copy constructor is a one-line function if you have an assignment operator already created. It returns CX string end sign. So a reference on their own class type. The end sign is after the name. And as argument, it takes a const pointer to a reference on the same type. CX string and then a variable name. Not a pointer, just an end sign after it. And the variable name, it's customary to call it other. Yeah. Okay, so there are three things we have to do. First, we have to release any memory that might be already allocated. Second thing to do is we need to create a new memory to store the data. And third is we need to copy the string over. So we don't have a copy on write mechanism implemented here. So we cannot just assign the m from the other object, because then it would be shared and then the thing would become inconsistent. So we need to make an own copy of m and just copy mp data from one to the other completely. Length. Now we need to access other. And we can use the length function, because other in principle might not have an m yet defined. So the other, exactly like this. Instead of accessing m directly, we access it through the length function. On the bottom here. We need to assign the result of create to our own m, which has been cleared already. We need to copy mp data and uLength as well, since they need to be the same. And you need to assign m is equals create, otherwise it will not be saved. In line 36, just like at the top. Yeah. No, we already know the length. You can query other length to get the length, and then we know what to copy on and what to not to copy. Um, Not quite right. Line 39, it should be m data first, because we want to copy it into our m. And instead of here you can use other asterisk c underscore str. Sorry, error. Like minus and other, then dot, normal dot, cstr. I see the mistakes in a few lines. So for example, in line 37, you also need the dot instead of arrow, and you should use the length function and not ulength, because ulength is a member of m, but you want to access the length function. Like in the line above, just that the line above is obsolete. We have it twice, so just other dot length. Make it no. It's an arrow when it's a pointer, and it's a dot when it's a local variable or reference. No, here also other length. And that at the very bottom, line 39, mu length. Okay. We need to return asterisk this. We need to return asterisk this semicolon. Yeah. I think if you do it in one line, it might opt to use the copy constructor. So to really check whether the assignment operator works fine before we have a copy constructor, just make a second line where you do the assignment. It cannot output mycopy. You need to use mycopy.cstring. Okay. So now we're only missing the copy constructor itself. Yes? Well, yes. So no, it's not. It's not defined. It's not defined. If it would be defined, it would be. Now it's local. If it's not, then it's this m. because the instance which already exists may have a different length or might not exist at all. Well, but then you are saying it yourself. Then you have like still just one object, but two pointers on the object. But what we are creating here are two independent objects. So now we can modify one of the strings, and the other string will stay what it was before. So in C#, if you would try to write your own string object, then if you would assign it just with a normal assignment operator, and then you would modify one of the strings, the other one would also get modified, and that's not what we want here. We want the strings to be independent, so that if we take one string and then we change it, then only the new string is changed and the old string remains what it was. Yes, then you're just using a pointer. So if you want a string which gets modified together, then what you're doing here is just my ptr, and then you assign my pointer with a reference on this, and then here you just need to use the arrow operator, my ptr. Okay, any more questions? Okay, so if we don't have questions, then we should quickly add the copy constructor, and this is quite easy, because within the copy constructor we just need to call our assignment operator. So asterisk this. Okay, now you can test it as well. Mm-hmm. Looks like it's working. Okay, so that's that. Now let me have the mouse again. Yeah. So this is already quite nice. So we can improve this in a few ways. First is we can type def ourselves a new type. Let's see. And another type. And now we can use just CA string instead of always writing this. This is quite useful. One limitation, of course, is CA string and CV string cannot be assigned one to the other, so they are incompatible because they are using different character types. And another thing that is a bit not ideal is that if we are returning a string, let's say make a make string function which just returns us some test string. So when we step through it, you will see that it will do a bit more operations than we would usually consider necessary. Let's see if we can normally separate. So we are inside the function, so we go in. Then we have, of course, the constructor. We step out. Then we have the return. Okay, it does not step for us, so let's add a breakpoint in here and in here. Okay, then let's disable the other test cases. Let's put a breakpoint here, and if we run it, interesting. In principle, when it returns the value, it should end up invoking the copy constructor, but it does not do that. So let's see why. So we'll just quickly change a few settings so that we get a cleaner output. Code generation. Disable this. And disable this. Disable this, that should generate cleaner code. Okay, so we go into our function. We have a few too many things enabled, so let's see what did I not disable. This should be disabled as well. Okay, now it's cleaner. Is it? It should be. Okay, now we step directly into our function at the top, and then go into our constructor as we should. Okay, that is it optimizes even in debug, but normally it should not optimize, or the older versions of Visual Studio did not optimize this much, so we need to think about how to make this less optimized. So let's generate two strings, temp1 and temp2 test. Now if which temp1, okay, we added a bit complexity to our function. And now before we return, you see we are ending up in the copy constructor, which then again does the assignment. So the way this happens, if we step through it step by step, here is we are entering our function. So now we are here at the top. We will be creating one string, we'll be creating the other string. So we could step maybe until here. Then we do the decision what we want to do, and then at the end we need to invoke the assignment operator to return the value, and this means that we have like allocated memory once for one string, then for the other string, and now when we are returning, so when you go out of this and out of that, here when we continue stepping, we'll see that we will be also arriving at the destructor for the one string and then for the other string as well. So it is not perfectly efficient. If the function is super trivial, then the compiler in the newest version is already smart enough to use the memory intended for the return, such that it omits this unnecessary creation of a copy, but it cannot return the strings the way you would like it. So we could maybe also make those static so that we don't need to create them each time. That will add a small optimization. So we can now go inside here. Okay. So we do the assignment. So this approach already saves us since we don't create and destroy the strings, but of course this is not usually a good solution, since we might want to create those strings dynamically, and then of course they cannot be static. So what we can do instead to simplify the return process is there is a special constructor type. It's called the move constructor, and it uses quite a strange syntax, because it uses this double end, which kind of in this way in C is not really something that was intended this way. So just when they extended the language with the ability to create such a move constructor, they just needed to find a way how they could make it distinct from the normal copy constructor. So they just went with this nonsensical notation. And what this thing does is it should be able to just as the name says, move the data from one to the other. So in this case, m is equals other m, and other m is equals null. And ideally, now when we run it, it should bring us into this constructor instead. Right, this should not be const, of course. So we have again here our function. Let's put a breakpoint on both returns. Oops, I pressed play once too much. Okay, we are here now. When we step by step we see that we end up in this new constructor, and the nice thing about it is that here we don't need to go through this create process, because we are just really taking over the ownership of the internal data object of the previous string class. So we take over the ownership, then we will of course arrive at a destructor for the other string, for the one that we have not returned. Then we arrive at the destructor for our own string, so this is why we needed to set here this m to 0, so that we don't longer hold the ownership, and then of course we can return from the function. So this assignment, this move constructor is quite a useful tool. You can use it to optimize returns in this case, since we are still of course creating some additional allocations, then it probably is not the it does not optimize this that much. We only save like 50% of the effort. But of course, if we would have something that works, some more complex function, which returns different strings, then having this operator, this constructor available will help a lot to keep your program performant. Of course, if you would change the way our string is implemented to use just a copy on write mechanism, then we would not need this sort of optimization. But since we don't use copy on write here, it is quite a useful new functionality. Okay, so let's see what we want to do next. So we will need to add, of course, a lot of functionality to our string so that it is useful. So I guess the next good step would be just to write down a few things which you will want to have in our string. So we will, of course, want to have comparison operators. We want to have a substring function which returns a portion of a string. So let's quickly maybe write those down. And substring, so this will all be the different to-dos that we will implement during then next exercises. So here, for example, the substring function will benefit from our move operator. So the way this works is it takes an offset somewhere in the string and it takes an optional length. By default this is -1, and what it does is it returns a portion of the string starting at pos and either going until the end of the string or until the u length is reached. So it's quite a flexible function. Here, of course, we will be returning empty things for now. Oops. What's also usually quite useful is a small helper function which they return just the specified amount of characters from one of the sides of the string. Then of course the next useful function is trim, which trim removes white space at the beginning and the end of a string. So again, this will just return a copy, but a trimmed copy. And then we will also want a find function. So find is extremely useful for any sort of string processing. And the way it works is it returns the position if it found it, or it returns -1 if it did not find it. So find so by default, of course, we search from the beginning, but we might also decide to search from any offset. So you can like find something and then you remember where it returned the position, you do something with it, and then you increment the position and then search for the next occurrence of the same string. And of course, likely useful is the reverse find, we just find from the end. Here, of course, it's position -1. It also will return. Yes. Um, yeah, it is unsigned, but if you are using -1, then it just means that all the bits are set to 1. So like -1 is like a placeholder for max value, and the advantage of using actually -1 instead of any definition of a max value is that if you define a max value, then you need to define it for which length. So if you would have if you would compile this project for a 32-bit system, then max value would be 4 billion something, and if you compile it for a 64-bit system, then it will be 16 whatever. I don't remember, I think sextillions or something like that, a really large number. But if you use -1, then in both cases, on both bitnesses, it will evaluate to just all the bits are set to 1, which is a nice pattern to identify non-existing or not valid return values. You're welcome. Okay, I think for starters this will be already good enough to have a useful string. There are additional functionalities which are, let's say, which can be even more useful. That is, for example, if you implement the ability to split a string by a token into individual strings, into a list of strings. But for this to work, here we would of course need an own list of strings, basically. So a list that can hold strings. So we would need to create a new container object, a well, XList. So this will be something for later. And now let's think about what of that would be easy enough for a homework. And the thing is that, of course, we should find homework assignments which can be turned in late, so that we don't say that in the next lecture we already need that functionality to implement the next thing. I should have thought about it in front. So usually a good assignment is rfind, because it's kind of a variation of find and we don't need it, but we didn't had time to implement find. So rfind will be the homework that will be assigned during next lecture. So during the next lecture we'll implement find. Left and right are also good assignments, as there are variations on substring. And the thing is, for the normal find you might already need compare, so not necessarily. Yeah, I think this is a reasonable thing to do. Okay, so as you remember from the int we created last time, we just create one function and then expand it like this to work with the other types. So just that, of course, instead of big int, this thing takes compare, capitalized compare other. So this will be the assignment. 31 10 2024. Yeah. Okay. And of course we need to find a definition of what is to be considered larger. And I think the simplest approach is to just first go by the size, and only if the sizes are the same then look in deeper, since this is a very efficient approach. Although it would not be good if you would want to use this function to sort a string list. So it is good if you need just something that will tell you whether they are different and how they are what's the right word? If you need to have some sorting, like for example, if you're using some sort of container which can allow you to efficiently retrieve elements, then you need some hierarchy of elements. But you don't really care whether this hierarchy is for a human intelligible or not. So in this case, sorting strings first by length and then only by the content is a good approach. But if you want to sort a list that you show to a user, then you would expect the list to be sorted alphabetically, which would not be the case if they are first sorted by length. So then you would basically have, like, for every length a list which is then sub-sorted alphabetically. So here for this compare, I think we should go with an approach where we will effectively sort them alphabetically. Okay, and the way this works is that even if the strings have different lengths, since we have a terminating null, you just take the length of the of either of the strings and then just go through the amount of elements, and as soon as you have a mismatch you can break out of the loop and return your 1 or -1. So it is a reasonably simple compare function, and even if the strings have a length mismatch, as soon as you are at the memory position for one of the shorter string where it has the 0, then at this place you will see that they are not the same, and then you can break out of the comparison. Okay, any questions? Okay, if there are no questions, then I think this is a good point to finish for today. I will upload the recording to Moodle and the project as well. And as mentioned, during the next lecture we will first implement substring, then maybe find and rfind, and left right will be left for additional homework. And once we are done with the string, we will take a look into implementing an own list container. And once we have the list container, we can then return to our string and add to it the ability to split and to join lists of to split a string into a list of strings and to join a list of strings back to a single string. This is quite useful in many scenarios when you are parsing data, or when you are constructing some data from a string. Good, so that's that, and we will see each other in 3 hours for the lecture. See you.